Welcome back. Today we are going through lesson 13.2, which is all about angles of rotation. So we're going to take some of that trig we've talked about and apply it onto an axis. So we're going to start, we're going to go through four kind of basic things with angles of rotation. And the first thing we're going to talk about is what's called standard position. So standard position is when an angle has its initial side on the positive x-axis and is rotated about the vertex from there to the terminal side. So we start with our initial side here on the x-axis, on the positive side of the x-axis. We rotate that side around and it ends at what's called the terminal side. So let's dive a little more into that vocabulary. So an angle of rotation, so that's where we are going to take the measure of an angle that's in standard position. So in our example that we had before, the angle of rotation is the number of degrees of this arrow, essentially. So how many degrees did it take to rotate it from the initial to the terminal side? That initial side is always a ray. So remember, that's where it has an ending point and goes on forever along the x-axis. So that's that blue that we highlighted in that picture. The terminal side is also a ray, and that indicates the end of a rotation from the initial side. So the terminal side is where it ends. So then we have the standard position, which we've talked about up above. That's an angle whose vertex is at the origin, so always at that 0, 0 spot. And its initial side lays on the positive x-axis, so what we highlighted in blue. So these angles of rotation can have positive measures or negative measures. So an angle that rotates counterclockwise from the initial side has a positive measure. And a negative measure comes from an angle that rotates clockwise from that initial side. So if we want to look at that in the picture, the arrow that we indicated in orange there, that's going in the positive direction. If it was negative, it would be going from that initial side downward in the clockwise direction. So that's kind of the vocabulary that we need to focus on there. Let's look at some examples of how to draw some angles in standard position. And so remember, standard position, they're all going to start along that positive x-axis. So we can always start with that as the initial side, and then it is rotating 60 degrees. So if you remember in angle measurements, that's 90. So 60 degrees is going to be a little over halfway. And that my angle measurement would go this way. So that's a 60-degree angle. The next one is a 200-degree angle. So 200 degrees, again, starts here. It's going in the positive direction. So I know that over here, halfway is 180. So 200 is just going to be past that a little ways, about 20 degrees. So something like that. All right, let's look at negative 45. So starting along that positive x-axis, now I'm going negative 45 degrees. So that's going to be halfway in that negative direction. All right, and then our final one is 390. So when I think about 390 degrees, that's more than one full rotation. So it starts at that initial side on the positive x-axis. It goes around one complete rotation plus another 30 degrees. So it looks something like that. And we indicate that it's gone around more than once with the drawing of the actual angle. So those are the three examples of standard position angles. So using that same concept, we are going to look at two more types of angles we might see. So for these, we might see what are called coterminal angles, and that is any angle where they have the same terminal side. And we can find coterminal angles by adding or subtracting 360. Okay, so if we want to write that out, when we add or subtract 360, we're adding it from the initial angle. So we would take our initial angle theta and we would add or subtract 360 degrees to get a coterminal angle. So as an example, I could start with a 45-degree angle, let's say. So here's my theta to start with. It's 45 degrees coming from that positive x-axis. So if I wanted to add 360 to that to get a coterminal angle, I would rotate around one whole rotation. There's my 360 plus another 45 to end at that exact same spot. So that green angle that I drew where it went around one whole time plus another 45, that would be a 405-degree angle, ending at the exact same spot. So co meaning same, terminal meaning end. So they have the same end spot. We can find coterminal angles over and over again. We can just keep adding 360 or keep subtracting 360 to go into the negatives. The other type of angle that we might see is called a reference angle. So a reference angle is the positive acute angle that's formed by the terminal side and the nearest x-axis. So let's look at an example of that. So let's say I have an angle over here from my initial side going around. So let's say that's a 130-degree angle. However, the closest or the nearest x-axis is from there over to the other side of the x-axis. So in this case, the reference angle is how much further it would go from 130 to get to that next axis at 180. So that would be a 50-degree reference angle. It would take another 50 to get to the closest x-axis. So let's look at these examples. So the first two are finding positive and negative coterminal angles for each one. So this first one is a 120-degree angle. So I'm going to start by sketching that initial angle. So here's, let's see, 120 is about there. So there's my initial angle of 120. So that would be our theta. So I am going to take that theta and I am going to add and subtract 360 from it to find a positive and a negative coterminal angle. So positive, I would take 120 and add 360. And when I do that, I get 480. So again, that coterminal angle just goes one full lap around and stops at the same spot. So that would be a 480-degree angle there. And then if I want to find a negative version of that, I would take my initial theta and I would subtract 360. So 120 minus 360 is negative 240 degrees. So that, and I go clockwise and at the same spot. So that angle going in the clockwise direction would be negative 240 degrees. Okay, let's look at our next one. So our next one is a negative 40-degree angle. So starting here at my initial side, going negative 40 is about there. And then I'm going to do the same thing. I'm going to find a positive one by adding 360 and a negative one by subtracting 360. So if I take negative 40 and I add 360 degrees, that gets me to 320. So 320 is a positive coterminal angle where I start at that initial side and go around in the positive direction to end at the same spot. To find my negative, I would take that initial angle and subtract 360. That would get me to negative 400. So that is starting at that same spot, now going around one full time and ending there. So that would be a negative 400-degree angle. For example 3 here, we are going to find the reference angle for each angle. So remember, the reference angle is the distance or the angle measure from the terminal side to the nearest x-axis. So 295 degrees, that's going to start on this initial side and go around past 270, 25 degrees. So it looks something like that. So our initial amount of theta is 295. So now I need to find the distance between that and the nearest x-axis. So that would be over here. So I know that I'm at 295. To get to the end there, I have to go to 360. So I need to find that distance between 360 and the 295 degree angle that I'm at right now. So if I subtract those, I get 65 degrees. So my reference angle is 65 degrees because it's 65 degrees from the terminal side to the nearest x-axis. To look at another one, we're going to look at 100 degrees. So that one starts on that initial side and goes just past the 90 degrees right here. So there's my theta of 100 degrees. And now I need to find the distance between that and the nearest x-axis. So the nearest x-axis is coming over here. And I know that that is 180. So I need to find the distance between 100 and 180. And I know that that is an 80-degree angle. So my reference angle there is 80 degrees. My reference angle over here was 65 degrees. Now that we have kind of some vocabulary to go with it, we've got angles of rotation, we know what standard position is, we know what coterminal and reference angles are. Now we can kind of start to put it all together on our coordinate plane. And so when we have an angle in standard position, we can use it to find the trig functions of theta. So given a point P that's on the terminal side of an angle in standard position, so you can see that in the picture over there, if we have P that's on this terminal side, then the distance from the origin, so let me kind of draw this while we go, from the origin to that point P, so this distance here is given by r, so think radius, equals the square root of x squared plus y squared. So when we look at that in terms of labeling things, this distance we call r, and it's given if we take the distance along the x-axis squared plus the distance it is in the y direction squared. So think kind of Pythagorean theorem going on here, right? So if we take that all into consideration, then I can use those labels to help me determine the sine, cosine, tangent, and then the cosecant, secant, and cotangent. All right, so using our picture there, if we have sine, remember sine is opposite over hypotenuse. So opposite of my angle is y. And the hypotenuse of that right triangle is r, or the radius. Cosine is adjacent over hypotenuse, so that would be x over r. And tangent is opposite over adjacent, so that would be the y direction over the x. And then remember, cosecant, secant, and cotangent are our reciprocal functions, so that means that each one is flipped. Cotangent would be x over y. So you will also notice that for these reciprocal functions, they're saying that x and y cannot be 0, and that's of course because we can't divide by 0. So the x distance or the y distance can't be 0. It means it can't be on one of the axes to find those trig functions. Okay, so let's put that into practice here. So looking at example 4, they are giving us a coordinate point, that point P, that's on the terminal side of theta in standard position. So if I think about this point, -3, 4, I would go left 3, up 4, and put a point. So if I make that into a triangle there, this is -3, and I've gone up 4. So theta is going to be right in here, and I am going to use that to find r first, and then once I have all three sides, I can fill in those trig functions. So let's find the distance of the hypotenuse here. So remember, to find that, we take the square root of the x distance squared plus the y distance squared. So simplifying that, I get the square root of 9 plus 16, which is the square root of 25. And so that tells me that r is 5. So my hypotenuse is 5. Maybe you remember that 3, 4, 5 is a Pythagorean triple, and we're able to figure it out that way as well. Okay, so now I can use that to fill in my 6 trig functions. So remember, sine is y over r. So my y distance was 4, and my r is 5. Cosine is x over r. So the x direction was -3, and the r is 5. And tangent is y over x. So that is going to be 4 over -3. And then I have my reciprocal functions where I'm flipping those. So this one would be 5 over 4. This one would be 5 over -3. And lastly, I'd have -3, 4. So we can use that standard position angle to find some trig functions of anything that we need to. Okay, last thing for these angles of rotation is to think about the signs in each quadrant. So depending on where the angle lands in standard position, that will allow us to determine whether the 6 trig functions are positive and or negative of that angle. So let's look at what's going on here. So in quadrant 1, we can see that both the x and the y are both positive. So that would mean that r is also positive. So if everything's positive, no matter what two numbers I'm dividing, all of my trig functions are going to be positive. In quadrant 2, I have a negative x and a positive y. So in that case, anything involving the y is going to be positive, but if any of the ratios have x in them, they're going to be negative. So sine and cosecant both just have x over r or r over x. Y. So sine and cosecant, those both just involve y and r, so those would both be positive, meaning when I divide them, I get a positive. However, cosine, secant, tangent, and cotangent all involve the x in some way, so when I divide a negative and a positive, I get negative answers. Okay, in quadrant 3, both x and y are negative, so anything that involves a negative and a positive is going to be negative, so that would be sine and cosecant and cosine and secant. But when we get to tangent and cotangent, now we're dividing y and x, and a negative make a positive. So in quadrant 3, tangent and cotangent would be positive. And then lastly, we have quadrant 4, where the x is positive, but the y is negative. So it's kind of going to be reversed from what quadrant 2 is. So in quadrant 2, we had the y over r was positive. Now my y value is negative. So when I divide a negative and a positive, I'm going to get a negative. In cosine and secant, I have x over r. And in that case, when I divide them, I am going to get a positive because the x is positive. And then lastly, I have tangent and cotangent where I'm dividing a negative and a positive. That's going to give me a negative answer as well. So let's use that to kind of see what's going on here. So here's the kind of question you might see around this. The terminal side of theta in standard position is in quadrant 3. So I know it's going to be in that bottom left quadrant. And the sine of theta is -4 over 5. So remember that in quadrant 3 or in any quadrant, sine is y over r. So I know that that's my y and that's my r. So if I draw an angle in quadrant 3, the sine, the y distance is -4, and the r is 5. So I can kind of use those to label what's going on there. Once we know that, then we can find the remaining x side. So I am going to use that Pythagorean theorem to kind of help me. So I'm going to find x by taking the square root of 5 squared minus -4 squared. So when I simplify that, I get 25 minus 16, and that would be the square root of 9. So I get an x coordinate of 3. Once I know those, then I can start to fill in my 6 trig functions. So sine of theta, remember, is y over r, so that's going to be -4 over 5. They gave us that in the problem. Cosine of theta is going to be the x value over 4, or over r, so that's going to be 3 over 5. And then tangent, remember, is y over x. So the y value over the x value. And then I can fill in my 3 reciprocal functions by flipping those over. So 5 over -4 for cosecant. Secant of theta is going to be 5 over 3. And cotangent of theta is going to be -4/3. All right, that is all about angles of rotation. We'll see you next time.